Okay, let us see one problem of associative memory. Associative means input and output are same. Some data it is stored, you are just trying to match whether the given data it is matched with the stored data. So in this case input and output both are same. What kind of problem will be there? The question is train the neural network for the given input. Okay, so first part it is for training and second part it is for testing. So in this case let us see one simple example. Some input it is given to you, xi it is equals to 1 minus 1 1 and 1. We want to train this input with the associative memory, and also we need to test it. What testing I am using? Let me consider. I am considering two wrong values. Now if position is not defined, you can take any position, any two values you can consider as wrong. It will give you the same answer, any positions. But if it is defined, first two values are wrong, then accordingly you need to consider it. Okay, let us complete the first part, training the given neural network with associative memory. What is the first thing we are trying to understand? That input and outputs are same. We can apply Hebbian rule, but we are using this shortcut here. We are finding the weight matrix. So how we are finding the weight matrix? We are taking product of xi with xi. So xi transpose with xi, this product we are taking. So let me show you this. 1 minus 1 1 and 1. What is size of this? Total 4 rows are there into 1 column is there, into xi 1 minus 1 1 and 1. So dimension of this is total 1 row is there and 4 columns are present. So what you will observe? Final whatever the product will be there, its size will be 4 by 4. Total actually 4 inputs are there and 4 outputs. So connecting weights 4 into 4, that is 16 weights will be there. So that 16 weights we are going to find out. So W is equals to, take the product, 16 weights will be there in a matrix of size 4 by 4. First row, first column. First row, second column. First row, third column. First row, fourth column. So it is 1. Minus 1 into all the terms. So it is equals to minus 1 plus 1 minus 1 and minus 1. Third row it is 1 minus 1 1 and 1. Fourth row it is 1 minus 1 1 and 1. Okay, first row, first column, first row, second column, first row, third column, first row, fourth column. This will gives me the first row, and similarly minus 1 into all columns gives me the second row, third row into all the column, third row and fourth row into all the columns gives me the fourth. So this is weight matrix where we updated all this required 16 weight. So first part of the question it is completed, that we trained the given neural network for the given input. Now what is the second part? Second part it is of testing. So for testing, see what they said, two wrong values. What I said you can consider any two of the values are wrong. Position it may be anything, but if it is defined properly, first two values are wrong, then accordingly you can make the changes. So if first two values are wrong, minus 1 plus 1 1 and 1. What I did? Wrong values. So in this input you are changing the values by minus 1. So this will becomes minus 1, this will becomes plus 1. These remaining two are as it is. We are testing for it. Now how we are testing? We will find out net input, that is weighted sum. So we will take the product of xi into matrix wi. So this product we want to take. So for this xi minus 1 Which xi you are considering? Testing input. Minus 1, 1, 1 and 1 into what matrix we are considering here? This weight matrix. So 1, minus 1, 1 and 1. Minus 1, 1, minus 1, minus 1. 1, minus 1, 1 and 1. 1, minus 1, 1 and 1. Okay? See what is size of this? Total 1 row is there and 4 columns. And here 4 columns into 4 rows. Okay, so let us take the product. What will be the final size? 1 into 4. This will be the size. So total 1 row will be there and 4 columns will be there. First row into first column. 1 into minus 1. It is minus 1. Then 1 into minus 1. It is minus 1. 1 into 1 plus 1. 1 into 1 plus 1. So finally minus 2 plus 2. So this will be 0. Then again first row into second column. So minus 1 plus 1. 1 into 1 plus 1. 2 now. 1 into minus 1. It is minus 1. 1 into minus 1 minus 1. So minus 2. Again it is 0. We are going for the next one now. So this row into third column. So minus 1 into plus 1. So minus 1. 1 into minus 1. It is minus 1. So minus 2. 1 into 1 plus 1. 1 into 1 plus 1. So again this is 0. Again this row into this column. 1 into minus 1. Minus 1. 1 into minus 1. Minus 1. Again plus 1 and plus 1. So again it is 0. See, all the elements are 0, 0, 0. So this is the weighted sum. Let us find out the output. What will be the output? Y is equals to phi of z. How we are finding this phi of z? It is equals to 1 if z is strictly greater than 0 and it is equals to minus 1 if z is less than or equals to 0. So all the elements are 0, 0, 0. So for this 0, what will be the output? Minus 1, minus 1, minus 1 and minus 1. Now this is the output. Testing means what? Whatever the input we consider, whether we are getting the same output, because in auto-associative input and outputs are same. So in testing we consider missing values. So what was our input? 1, minus 1, 1 and 1. But by using this neural network, we are getting the output as minus 1, minus 1, minus 1, minus 1. So what is the conclusion? Our neural network fails to retrieve the output. It is not same, it is different. Many of the time we observed for 1 missing value, for 2 missing value, even for 3 missing values also, you will get the same output. But in case of wrong, after 1 means if 2 wrong values are there, most of the time we observed our output it is not same as input. So this care you can take. Auto-associative, it's very easy. You just need to remember that input and output are